In this question, we are required to find the gradient of the tangent to this curve at the point pi pi. Now, before we find the gradient of the tangent of this curve at this point, we need to find the gradient function, or dy over dx, in terms of x and y. And to do that, we shall differentiate this equation implicitly. So for part A, we can start by differentiating this equation implicitly. Minus. Now, because this is a product, we can use product rule, differentiate that. And then the derivative of 0 is just 0, so I'll just leave it as 0. So derivative of 2x squared will be 2x, and then derivative of sine y will be cos y. That's outside. Inside, derivative of y is dy over dx, minus, here we'll have x multiplied by dy over dx, because derivative of y is just that, plus y being equal to 0. This also can be written as 2x plus cos y dy over dx minus x dy over dx minus y is equals to 0. So at the point pi pi, we can plug these x and y values into this equation. So we'll end up with 2 pi plus cos pi dy over dx minus pi dy over dx minus pi is equals to 0. Cos pi, which is same as cos 108, is negative 1. So basically, the resulting equation here will be 2 pi minus dy over dx, because that's negative 1. And by the way, 2 pi minus pi is just pi, so we can just write this as pi minus pi dy over dx is equals to 0, which implies that now we can factorize out negative 1 and factorize out dy over dx. So this portion of the equation can be written as negative into 1 plus pi multiplied by dy over dx. And then this can be brought to the right hand side, so you have negative pi. So which implies that dy over dx will be equal to negative pi over negative 1 plus pi, which will be equal to pi over 1 plus pi. Okay, so that is part A of this question. For part B of this question, we are required to show that tan theta is equal to 1 over 1 plus 2 pi, where theta is the acute angle between the tangent to the curve at this point and the line y is equals to x. So theta is an angle between an acute angle between the tangent line and the line y is equals to x. Now there's something that I'm going to write here that will be helpful here. Yeah. So the acute angle theta between two lines whose gradients are m1 and m2 are given by the tan of m1 minus m2 over 1 plus m1 multiplied by m2. So basically, the acute angle theta between two lines. And in this case, we have the tangent line and the line y is equals to x. All right, so the acute angle theta between two lines whose gradients are m1 and m2 is given by tan theta will be equal to absolute value, because we want the acute angle. So absolute value of m1 minus m2 over 1 plus m1 multiplied by m2. Now, in our case here, m1 will be the gradient of the line y is equals to x. So m1 is just 1. And m2 will be the gradient of the tangent at pi pi, which is given by pi over 1 plus pi. So, and by plugging these two, m1 and m2, into this formula, we shall actually be answering the question, which is we are required to show that tan theta is equals to that. So tan theta in this case will be equal to absolute value. No need actually to write absolute value because it's an expression. So m1, which is just 1, plus m2, which is pi over 1 plus pi, over 1 plus the product of m1, which is just 1, multiplied by pi over 1 plus pi. Okay, so we can rewrite 1 as 1 plus pi over 1 plus pi, so 1 plus pi over 1 plus pi, just so that we can have the same denominators, plus pi over 1 plus pi. Let me use brackets. And then here we can have again 1 plus pi over 1 plus pi plus pi over 1 plus pi. Okay, and this will be equal to, so here, oops, I think I made a mistake. This is minus here, so that's minus. So if you subtract these two, that will just be equal to 1 over 1 plus pi over, now here, pi plus pi, that will be 2 pi plus 1, so 2 pi plus 1 over pi plus 1. Now if you divide this, of course the denominators are the same, so they will just cancel out, so you'll end up with 1 over 2 pi plus 1.